35 cents. Well, I should say cents. So it says at least 35 cents, so that means it could be 35 cents or more. So let's look at all the choices that she could make. And I'll write them like this. She could reach into the bag and she could pull a 10-cent coin and a 10-cent coin. That's a possibility. She could reach in the bag and she could pull a 10-center and then a 25-center. Or the reverse of that. You could pull a 25-center first and then a 10-center. Or two 25-centers is also a probability. Now you notice that this one doesn't get you the 35-cent threshold. This is 20 cents. So we can ignore that one for the moment. These all have 35 cents or more. So we want to find out what are the probabilities here. So the first one says, well, chance that she would draw a 10-cent coin on the first draw would be 5 chances out of 9. So it's going to be 5 over 9. And then chances that she'd pull a 25-center on the second one, well, there's still 4 of those 25 centers, but now there's only 8 coins. So this is equal to 20 over 72. That's the probability of that draw. Well, let's look at the next one. If she reaches in first and gets a 25 center, well, there's 4 of those out of those 9 coins in the bag. And on the second draw, there's only 8 coins, and she's going to draw a 10 cent. Well, she didn't touch the 10 centers, so there's 5 in there. So that's also 20 over 72. And then the last one is, well, let's see. She's going to pull a 25 center, and that would be 4 coins out of 9. But on the second draw, there's only 3 of those 25 centers left, and that's out of 8. So that's going to be 12 over 72. So we found the probabilities of each of those 3 possible draws that would give us at least 35 cents. So now what we're going to do is we're going to add them up. So it's going to be 20 over 72 plus 20 over 72 plus 12 over 72. And that's going to be the probability 2-coin draw greater than or equal to 35 cents. Well, we can add fractions that have the same denominator, and so we're fortunate here that they all have a 72. So 20 plus 20 is 40, plus 12 is 52 over 72. But you see, that's not one of the answers in our choices. So we have to simplify this. And we can do that by doing a little bit of factoring. You talked about the factoring tree maybe in one of your classes. So we say 52. Well, 52 could be, let's see, 2 times 26, and 2 times 13. So this would be 2 times 2 times 13. And then 72 would be 2 times 36, would be 2 times 18. So it's 2 times 2 times 18. 2 times 2 times 18. Well, these 2's cancel. Numerator and denominator are the same, so those are just 1. So the answer to this then is 13 over 18. I believe that is the correct answer. Now, before we leave this problem, at the start we said, well, let's not consider this one because that doesn't give us the 35 cents. But if we turn this on its head and saying that if this does not give you 35 cents, then if we looked for 1 minus the probability, in other words, everything but this, we should get the same thing. So let's go ahead and figure out then what is the probability of the 10 and 10. So the probability of the 10 and 10. Well, let's see. On the first draw, she's going to have 5 coins out of 9. And on the second draw, she's going to have 4 coins out of 8. And that's going to equal 20 over 72. But we said we wanted 1 minus that. So it's 1 minus 20 over 72. So that's 72 over 72. That's 1 minus 20 over 72. 72 minus 20 is 52 over 72. I think I've seen this number before, right? There's 52 and the 72. So we could do that too. Everything but this is 1 minus that. All right, so having presented that, rest easy, because I don't think it's going to be part of your future unless you take a probability class. As you can see how I laid it out, I just considered all the choices before us, put down the draws, and then multiplied each of the draws, and then added them across all 3 possibilities. Okay, so this problem says we're given a equation, y is equal to 6 times x minus a half times x plus 3. And they said, what is the y-intercept? Now that's why I mentioned earlier